This is the structure of an amino acid. This is the carboxylic group. This is the amino group. This is the R group. The different R groups determine the different properties of the amino acid. This is a condensation reaction. A condensation reaction happens when two amino acids join to form a dipeptide. As well as this, water is removed. A peptide bond is formed between the amino group of one amino acid and the carboxylic group of another amino acid. The primary structure is the sequence of amino acids in a polypeptide chain. The secondary structure is when the polypeptide chains are folded into alpha helix or beta pleated sheets. Tertiary structure forms due to chemical bonds and hydrophobic interactions between the R groups.
All enzymes are made up of proteins. Enzymes have an active site, which is a small depression on the surface of the molecule that has a specific shape due to the way that the molecule is folded. The substrate can fit into the active site of an enzyme by either the lock and key hypothesis or the induced fit hypothesis. The lock and key hypothesis is when the substrate fits perfectly into the active site. Each enzyme is specific to one substance, therefore only one substrate can fit into an active site. The induced fit hypothesis is when the active site molds itself around the molecule it recognizes. In this case, the active site isn't complementary to the shape of the substrate. Every enzyme has an optimum temperature, which is shown by the peak in the graph. At any temperature above this optimum temperature, the enzymes begin to denature. This causes the bonds to weaken, and therefore the enzymes start to lose their tertiary and quaternary structures. The denaturing of the enzymes is shown by the decreasing slope of the graph. When they denature, they lose their ability to catalyze reactions. When the temperature at which the reaction takes place is increased, the kinetic energy of the reaction increases. This increase of kinetic energy causes the rate at which the enzyme and the substrate moves to increase. Therefore, more collisions between the active site and the substrate take place, and more enzyme-substrate complexes are formed.
All enzymes have an optimum pH. This is shown by the peak in the graph. Enzymes will denature at certain pHs. This is due to charges on the H+ and OH-, pushing apart the bonds in the tertiary structure so that the substrates no longer fit the active site.
In a reaction, enzymes don't get used up. The first line shows a reaction that has not been catalyzed by an enzyme. The second line shows a reaction that has been catalyzed by an enzyme. Therefore, the activation energy of this reaction is much lower than the activation energy of the reaction that has not been catalyzed.